Hi everyone, today we're going to do a November 2017 practical exam on qualitative analysis. This video will include some of the tips and tricks on how to answer this question. So let's get started. We're given two mysterious solutions, solution R, which is a colorless solution, please take note of the color, and solution S, which is a blue solution. Now, cation can be easily be identified by its own colors. In this case, the solution S is blue in color, therefore, the solution might contain Cu2+. Okay, to 2 cm depth of a solution in a test tube, add aqueous sodium hydroxide until a change is seen. So first, I'm gonna go with solution R. So take 2 cm cube of solution R and add aqueous sodium hydroxide. White precipitate is seen. Okay, to this, I need to add an excess aqueous sodium hydroxide. Well, white precipitate dissolve in excess, giving a colorless solution. From the QA notes, the ones that give white precipitate and are soluble in excess are aluminum and zinc. Let's move on to solution S. Same thing, 2 cm cube of solution S. Add aqueous sodium hydroxide. Blue precipitate is seen. And then add excess sodium hydroxide. Blue precipitate do not dissolve in excess, so blue precipitate remain unchanged. By referring to the QA notes, the cation present in the solution S is copper because when aqueous sodium hydroxide was added, the solution S turns to blue precipitate and are insoluble in excess. Now, this leads to question 2a. To 2 cm depth of a solution in a test tube, add aqueous ammonia until a change is seen. As usual, we start with solution R, 2 cm depth of solution R, and add aqueous ammonia until a change is seen. White precipitate is seen. And then to the mixture from A, add excess aqueous ammonia. Keep the final mixture for use in C. White precipitate are insoluble in excess aqueous ammonia. So for R, I can say that it contains aluminum because in part 1, it gives white precipitate and are soluble in excess. And in part 2, it gives white precipitate and are insoluble in excess. Therefore, according to the qualitative analysis notes, the cation is aluminum and not zinc. Now, moving on to question 2c for solution R. To 1 cm depth of aqueous hydrogen peroxide in a boiling tube, add the final mixture from B. So, 1 cm of aqueous hydrogen peroxide, and then we add final mixture from B. So hydrogen peroxide is test for oxygen. So we need to warm this gently. Now prepare a glowing splint. It does not relight the glowing splint. Thus, for our observation, we write upon heating, it does not relight the glowing splint. Thus, no gas was evolved. Now for solution S, same thing, 2 centimeter cube of solution S. Add aqueous ammonia until a change is seen. Blue precipitate is seen. And then add excess aqueous ammonia. Blue precipitate are soluble in excess, giving a dark blue solution. So, when aqueous ammonia was added to the solution S, it gives blue precipitate and are soluble in excess, giving a dark blue solution. Therefore, by referring to the qualitative analysis notes, the cation is copper 2 ions. Next, question 2C for solution S. In a boiling tube, add 1 centimeter of hydrogen peroxide and then add the final mixture from B. Immediately after adding a mixture from B, the solution turns darker and effervescence is observed in the reaction test tube. Then again, we need to warm this gently and prepare a glowing splint. It relights the glowing splint. By referring to the QA notes under the test for gases, the ones that relights the glowing splint is oxygen. So on to the final question. To 1 centimeter depth of a solution in a test tube, add an equal volume of dilute nitric acid. So add 1 centimeter cube of solution R and add an equal volume of dilute nitric acid. No reaction is observed. And then pour half of the mixture from A into a test tube and add an equal volume of aqueous barium nitrate. Still no reaction. And then to the other half of the mixture from A, add an equal volume of aqueous silver nitrate. White precipitate is formed. So by referring to the qualitative analysis notes, for solution R, I can say that there is no sulfate at all because it does not give white precipitate during the addition of aqueous barium nitrate. However, it gives white precipitate when aqueous silver nitrate is added to the solution. Therefore, the anion is chloride. So let's move on to solution S. Same thing, 1 centimeter cube of solution S. Add an equal volume of dilute nitric acid. No reaction. And then pour half of the mixture from A into a test tube. And add an equal volume of aqueous barium nitrate. Still no reaction. And then to the other half of the mixture from A, add an equal volume of aqueous silver nitrate. White precipitate is seen. And again, by referring to the qualitative analysis note, so for solution S, there is no sulfate present because it gives no reaction when adding barium nitrate to the solution, but it gives white precipitate when aqueous silver nitrate is added to the solution. Therefore, the anion is chloride. Thus, what we write on the conclusion part, the compound in solution R is aluminium chloride and the compound in solution S is copper 2 chloride.